take it away.
Yes, welcome everyone to the Update Conference 2022. We are very happy to be here. I don't know if you saw the change in the program. We were actually on Friday in the afternoon, but somebody's plane was canceled, so now we're here to start off the conference. So we're very honored to start off the Update Conference for you guys today. Thanks for coming. My name is Edwin van Wijk. I work for a consultancy company in the Netherlands, Info Support. I'm a principal architect there, and I'm also a Microsoft MVP. And I do this session together with my colleague, Sander. Maybe you can introduce yourself.
Good morning. My name is Sander Molenkamp. I also work for Info Support.
This session or the description, it said that you had to have some knowledge of Dapr for this session, but we will do a 101 on Dapr, what Dapr is at the beginning. So if you have never heard of Dapr before, we will do a little introduction. So don't worry, we got you back. First of all, if you want to know, if you're interested in Dapr and you want to see a real-world example, not a Hello World example, but a real-world example of Dapr, you can check out this repository here. The link is up on the slide. And this is eShop on Dapr, and this is basically a port of the eShop on Containers reference application that Microsoft created. But we changed that, and we use Dapr to build this application. So if you're interested in that, check it out. If you want to know more in-depth information about how Dapr works, this is a tip. This is a book that we wrote together with people for Microsoft. It is for .NET developers, but also if you're not a .NET developer, you can get a really good insight into what Dapr is and how it works. So that's also another tip to start you off. So first of all, a little Dapr 101. What is Dapr? Well, Dapr stands for Distributed Application Runtime. And if there are people that are here for the DAPPER, the Dapr Micro ORM, this is not this session. So you can just maybe go to the other session. But this is about Dapr, the Distributed Application Runtime. And there's a really cool marketing term up here. It's a portable, event-driven runtime for building distributed applications across cloud and edge. Wow, that's cool. It can do everything. Of course, that's a really big sentence, but we always say Dapr enables you as a developer to start building business applications right away, and you don't need to worry that much about all the cross-cutting concerns that you run into when you build a distributed application. Things like pub/sub or service invocation, stuff like that, service localization. There's lots of stuff that you need to worry about when you build a distributed application, and Dapr can help you with that, and we're going to show you how Dapr can do that. So first of all, if we look at the history of Dapr, it was started somewhere around October 2019. It came from the Microsoft Azure incubation team, it started at Microsoft, but then in November of 2021, it was actually donated to the CNCF, the Cloud Native Computing Foundation, which basically means it's not owned by Microsoft, it's not a Microsoft-supported product, but it's completely owned and supported by the community, so it's open source. And the current status is incubating, and that means that it is considered stable, and it has actually been used in production workloads. So this is actually something that people use. And there are some reference cases on the Dapr side. So if you want to know about companies that use it in production today, go there and you can see some cool references. So what is Dapr? Well, Dapr basically is a suite or a set of building blocks that will give you these distributed application capabilities. We won't go over each one of them, but for instance, service invocation. If you want to call another service within your distributed application and you don't want to know where it lives, you don't want to know how to call it, you just want to call the service, right? Well, that's service-to-service invocation. There's also pub/sub in there, which is obviously for event-driven applications, this is really important. Things like secrets, well, you name it. There's a lot of building blocks out there. And what makes it really cool is that Dapr provides all these capabilities through a really simple HTTP or gRPC API. And that also means that basically from any application platform, from any application language or a programming language that you can do HTTP or gRPC calls, you can use these capabilities. So which makes it really easy to get started with Dapr. Obviously, there are also SDKs. We will make your life a little bit more easier for .NET, for Java, for Go. I don't know. There's lots of them out there. And it's all open source. So you can look at them, you can contribute to them. And yeah, it's really nice ecosystem. And then finally, it can run anywhere. You can run it on a laptop, you can run it in containers on Kubernetes, you can run it in the cloud. It runs basically everywhere. So that is what Dapr is. And what we're going to do today is we're going to look at a couple of demos of new features. That is why it's called Getting Up to Speed. And for you to grasp, if you've never seen Dapr before, what's really important to grasp is how Dapr works technically. And that is by using its sidecar architecture or sidecar pattern. So what you see here, you see some application code running. That could be your microservice or your application running in a process, perhaps on my laptop. And then next to it, a separate process is started with the Dapr sidecar. And this Dapr sidecar will offer an HTTP gRPC API, and then your application communicates with this sidecar to use all these capabilities. Also, this works inside containers. So if you're running your application, for instance, in Kubernetes, then you can make sure that if you use Dapr with that, that your application code that's running in a container inside a pod, because in Kubernetes you are running stuff in pods, then sidecar containers automatically inject it into the pod. And because within the pod, these containers can communicate over the local network, it is real easy. You can just call this Dapr HTTP or gRPC API. And this is how that works. So, this is important to keep in mind if we also look at the demos that we're going to do today. And what we're going to show you is some new developments, new features with the service invocation building block. We're going to look at some new features with the publish and subscribe building block. We're going to introduce a completely new building block, which is recently added, which is the configuration building block, and also a new building block to distributed log. So that's what we're going to do today. And with that, I'm going to pass it over to Sander to introduce the demo application that we're going to use today.
Yeah, so this is our Dapr traffic control sample, and we'll use this for our demos. I don't know how it's here in the Czech Republic, but in the Netherlands, we have a lot of these speed control trajectories. And the way they work is they use cameras above the roads to make pictures of your license plate, and then when you get to the end of the trajectory, they can calculate how fast you've driven, and of course if you've driven too fast, then you get a ticket and you have to pay a fine. So this solution consists of a couple of microservices. We have a camera simulation, which is just an ordinary .NET application. It's not Dapr enabled. And that will simulate our traffic for us. So that will generate some dummy camera events. Those are published to an MQTT broker. And then we have our traffic control service, which uses a Dapr input binding to consume those events, process them, and see if there have been any traffic violations. And the state that it needs to store for that, it uses the Dapr state management building block. We use Redis for that if we run it locally. And then if a traffic violation is detected, we publish an event using the Dapr PubSub building block. Those events are then handled by the fine collection service. So that service is purely responsible for coming up with an exact amount for the fine and then emailing it to the violator. So to email it, we use an SMTP Dapr output binding. I believe that's the one you wrote or contributed. Yep. Even. We also do some stuff with secrets. But to compose that email, we need a little bit more information. We need some details on the vehicle and some details on the vehicle's owner. So for that, we make a service invocation call to the vehicle registration service, which provides us with some dummy data. So basically, within this single solution, we try to use all of the Dapr building blocks. Now, for this first feature that we'll look at, we'll focus on service invocation. So that's just going to be this area of the solution right here, the communication between the fine collection service and the vehicle registration service. And that first feature is called gRPC proxying. So this is a really great feature if you have existing gRPC services that you want to call from your Daprized applications. Now, with service invocation, the goal obviously is to invoke some remote servers somewhere. And normally, you would just make a direct call to that service, right? If you want to call a remote gRPC service. But in the case of Dapr, you are not directly calling that service anymore. You are making a call to your local sidecar. So you can do that using either HTTP or gRPC. And then your local sidecar will take your request, wrap it, find out where the target service is, where the sidecar of the target service is, and forward the request to that sidecar. And it uses gRPC for that, because sidecars always use gRPC to communicate with each other for performance reasons. Then finally, that target sidecar will invoke the actual service that you want to invoke. And again, that can be either HTTP or gRPC, depending on what type of service it is. Now, the benefits that you get from having these sidecars in between, there's actually a lot of them. So first of all, you get this automatic service discovery. You don't need to know where that other service lives. These sidecars will find out for you. If anything goes wrong between those sidecars, Dapr can automatically retry those requests for you. You get built-in distributed tracing and observability. That's a path between those sidecars that's encrypted with MTLS by default, so that's security out of the box. You can specify who is or who isn't allowed to call into your servers. You can even use API token-based authentication on top of that. So that's a lot of benefits that you get from now having this Dapr layer in between those services. Now, this has always worked really, really well for HTTP services. But early versions didn't work quite so well for gRPC services. So let's say that my vehicle registration service is a gRPC service, right? So I have a protofile. So this protofile defines the schema and the operations for the gRPC service. And I use that protofile to generate some code to implement my service with. Now, in an ideal world, if I would now want to call that service using Dapr, I wouldn't have to change anything to this protofile or to my code, right? I just want to call it through Dapr. I don't want to have to rewrite it to make it callable through Dapr. Unfortunately, up until I believe it was version 1.7, so somewhere about, you did have to make quite a lot of change to your gRPC service, because you had to implement this very specialized Dapr protofile in order to make it callable through Dapr. And this is a very generic protofile, and that means that you have to do all of the mapping and the serialization yourself, and you have to really rewrite that service. But now with the gRPC proxy feature, it's very easy to make an existing gRPC service callable, and let me just show you how that works. Now, big disclaimer here, this is not my laptop, this is Edwin's laptop. And this is a Windows laptop, and I'm totally used to MacBooks. So if things don't work out, it's because of the laptop. So here I'm in Visual Studio Code. We've got our solution open. This is the vehicle registration service code base. And here you can see I have this protofile, which I've just shown you on the slide. And I've used this protofile to generate some code. And now I've implemented my service with that. So here you can see the implementation of the get vehicle info operation, which is really simple. I just call into a repository to get some dummy data, some dummy vehicle information. I return that to the caller. So to make this service now callable through Dapr, I don't need to change anything to the code. The only thing I need to do is to make sure that I start it using a Dapr sidecar. So I've got a little script for this, but what it does is it starts a Dapr sidecar and it starts my process alongside that. So now both of these are running. The white colored logs are the logging from my sidecar, and the bluish ones are coming from my application. So this vehicle registration service is running. Now let's look at the find collection service, because that is the service that is going to call into the vehicle registration service. And in the find collection service, I have the same protofile that I use to generate some classes. And then I have basically this proxy service, which is my facade to call into the vehicle registration service. So what I do is create a new request. I call that service using this generated vehicle info client, and then I return the result. And to set this all up, I have in my program added this gRPC service. Where is it? It's over here, with builder services at gRPC client. So here I register that vehicle info client, and of course I need to tell .NET where my vehicle registration service lives. So this has nothing to do with Dapr. This is just a normal way that you would do it in .NET. Now, if we want to add Dapr to the mix, then of course I no longer want to directly invoke that vehicle registration service. I want to go through my sidecar. So I'm going to change this URL to the URL of my sidecar. And the way this is going to work is my file collection service is going to make a gRPC call to the sidecar. It's just going to pretend that it's the vehicle registration service. The sidecar will get that request, and it will look at it, and it will check to see if it's a standard Dapr API call, such as store secret or get some state. So if it's a standard API call, it will just do that. And if it's not, if it doesn't recognize it, it will assume that I'm trying to make a service invocation call. And then, of course, it needs to forward that call to the final service. But how does it know what service to forward it to? Well, that's the point where we do have to make a small change. So I'm going back to my proxy class here, and instead of just making this request, I'm going to add a little bit of metadata to it. I've got a snippet for that. So I'm going to set up metadata, and I'm going to add a key value for Dapr app ID. And in this metadata, I'm going to put the name of the service that I want to call. So that way, the sidecar knows, oh, you're trying to call the vehicle registration service. It will find the sidecar of the vehicle registration service, forward that request, and then call the gRPC service. So with all of this running, let me see, I was trying to open this one. I can now start that file collection service, if I can type correctly. And we should get some application logging. Yep, there it is. Now let's see this working. So I've got a little test file here, and I can trigger this file collection service by making a call to its event handler. So if I send this request, we should get back a 200. And if we now look at the logs, then in the file collection service logging, you can see that we've now sent a speeding ticket to Marchie Barrow. I don't know how we generate these names.
Just random.
Yeah. But we send a speeding ticket, and if we go to the vehicle registration service, we can see that it was called to retrieve that vehicle info. So this gRPC thing seems to work quite well. And now, of course, because we are using Dapr in between, we get all those benefits like observability, encryption, automatic service discovery. So if we open Zipkin, which is a tool for distributed tracing, and we now run our query, we can see all the traffic that we've just generated. So this is a bit of a nicer view to look at that. If you look at the dependencies, it's a bit small. I don't know if I can zoom, which is different on a Mac than it is on a, well. Anyway, this here says file collection service, and here is my vehicle registration service. So because of the traffic now going through those sidecars, we now have this nice distributed tracing basically for free out of the box. So that is what I wanted to show you about gRPC proxies. Now let me go back to my slide deck. Because calling services is all very nice if everything works. But when you're using Dapr, you are building distributed systems, and distributed systems will fail often, quite often, because there are so many different moving parts. You can have network hiccups, services may be restarting or upgrading. So this is a new preview feature that's not stable yet, but it's very usable already, called resiliency. So this provides you with a lot of different strategies to deal with a variety of failure scenarios. And the way this works is that you create this resiliency spec. And within this resiliency spec, you can specify timeouts, retries, or circuit breakers. So timeouts are basically just the early termination of some long-running process. And in this example, I've defined two timeouts. I've defined one called general for 5 seconds and one for card called 60 seconds. Then you can also define retry policies, which is basically how you want to deal with failures when they occur. And such a failure could be a timeout, for instance. So for example, if a timeout occurs, maybe I want to retry at a constant rate, have a duration of 5 seconds in between, and just retry 3 times before giving up. Or I want to have an exponential retry where the time between retries each time increases exponentially, plus some little bit of randomness added to it. And that max retries -1 here just means that I want to retry indefinitely. So it's very easy to define these policies this way. And then we also have circuit breakers. So circuit breaks are really great when you are encountering a lot of consecutive failures, for example, when calling a remote service. So in this case, if the consecutive failures is higher than 10, the circuit breaker will go into the open state, which means it will fail fast, so it will not let any requests through. And that's great for the failing service because it gives it a chance to recover. And then after some timeout, the circuit breaker will try letting some requests through again, and if those succeed, then the service must be healthy again, and the circuit breaker will close, and everything will continue as normal on the happy path. So this is the way that you can define these policies, but then you also need to apply them to a target, right? I want to do service invocation, I want to use this while I'm doing service invocation. And the way you do that is you specify targets. And there are a couple of types of targets actually. So the first one is apps. So here you can see that I've set up some policies for when I'm trying to call the vehicle registration service. So this basically says, when you try to call the vehicle registration service, if a timeout happens, recover using the exponential sample retry strategy. But it's not just service invocation that we can improve with these resiliency features. We can also do the same for actors when actors are trying to call each other, or when you're trying to invoke an actor from a service. And we can even use this for any Dapr component. And this is interesting because if you look at components, there are actually 2 types of scenarios that might happen here. We have outbound traffic, which basically means that the Dapr sidecar is trying to invoke some component infrastructure for us. For example, it's trying to publish an event to RabbitMQ, or it's trying to write a key value to Redis. So when that kind of outbound traffic faces failures, then we can specify outbound policies. But we also have the other side of the coin, which is when the sidecar is trying to invoke our application code. For example, when a pop-up message comes in or when an input binding is triggered. And then you can specify inbound policies. So those are all the policies. Let's just see how this works in actual practice. So let's start with this vehicle registration service again. Because I've shown you the gRPC implementation, but I also have an HTTP version, which is implemented in this vehicle controller. It's very similar. It's a get vehicle info method which just returns some dummy data. Only this time I've kind of screwed it up a little bit by making sure that every other time that you call this service, it will return a 503. So yeah, that's I believe the error code for service unavailable, yeah. Something like that. So let me just start this vehicle registration service in that HTTP mode. Start HTTP. All right, and let me make sure my find collection service is also started. And then I can go back to my test script. Okay, so what I'm going to do now, I'm going to use the invoke API on the sidecar of the find collection service. So I'm basically going to ask the find collection service sidecar to please invoke the vehicle registration service for me. And then, of course, what happens is that I get either a result back, like here, or I get a 503 service unavailable, because it just alternates between those 2 responses. Okay, so now we have basically this wonky servers, and let's say that we're running in production, and we need to fix this. We need to add some resiliency to make sure that we don't get those 503s. So the first thing I need to do is I need to opt into this preview feature. Because resiliency is still in preview, you need to explicitly opt in. So we go to our Dapr configuration file, and we need to flip this feature flag here. So we set resiliency to true. And then we need to specify that resiliency spec. And I've already created a retry policy here. So I've got a policy named general. This is just a constant retry policy. It will retry 3 times with a second in between. And now I need to apply this to my vehicle registration service. So I'm going to say, hey, when I'm trying to call the vehicle registration service, if anything goes wrong, please retry using this policy. So now I do need to restart define collection service because we just changed all that configuration. So this is working again, and then we go back to the test. And now when I send it, I get back a 200, which could just be a coincidence, so let's try it again. And I still get that 200, right? Because every time, even if a 503 comes back, it will just use that retry policy to retry. And you can see so in the logging, like here are log lines like error processing operation, yada, 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 and hey, we recovered processing the operation. So this is really great because without having to write any code, and just by declaratively defining what I want to happen in a failure scenario, I can now improve the resiliency of this solution. All right. Let's switch back and let's talk about publish subscribe, Edwin.
Yeah. So new features were added to the publish and subscribe building block. Publish and subscribe obviously is for sending messages to a broker, which will then be sent to subscribers to that message. The first feature I want to talk about is content-based routing, which is very practical to have. So let's do a little recap on how PubSub works. In this case, we have a cart service, some web shop shopping cart, and it wants to send a message that an order was created. You see the payload here. So it uses the Dapr publish API to send the message. And we have to specify which PubSub component to use. In this case, it's called message broker, and the topic that we want to send the message to, which in this case is orders. And when the Dapr sidecar will pick this up and will send this message to the message broker, which is in this case a RabbitMQ, but it could just as well be a Nets server or Azure Service Bus, whatever. And then multiple services can subscribe. So in this case, we have a shipping and a billing service that subscribe to this orders topic, and they will get a copy of the message. This is basically PubSub. But now make this a little bit more interesting. So let's say we start supporting within our company standard and priority shipping. But we don't want the cart to know about that, right? It's just want to say, okay, your order was created, that's the event, and I don't want to consider which endpoint I need to call or to which different topic I need to send it. I just want to send it to the orders topic, and then Dapr can figure this out. Well, with this new content-based routing filter feature, you can do this. So how does Dapr know where to send this message, to the standard or to the priority endpoint? Well, for that, you can now define rules. So you can define routing rules. So here you see a declarative way of creating a subscription to this orders topic. And in this definition, we find rules. And these rules define which endpoint the message will be sent to. So here we see two examples. If the type of the message is order, and in the data of this message, there's a priority field that has the value true, then it will be sent to priority endpoint. And if the value of the priority field in the data is false, it will be sent to the standard one. If, for instance, none of these rules match, you have a default one, which in this case is the standard endpoint. So by doing this, the Dapr sidecar can decide, oh, okay, this matches, in this case, priority is true, so I'll send this message only to the priority endpoint of the shipping service, which is pretty cool stuff. You can also define this in code, just as about everything in Dapr. You can do it declaratively, or you can do it in code. So here you see the same setup, but then with an ASP.NET Core web API. You see some controller actions, and then the same rules are defined for the topic attribute, which is how you can subscribe to a certain topic. Because in code, you also have to specify an additional priority. So you can also specify in which order these rules will be evaluated. These expressions, you have to write them in the common expression language, which is an open language. You see the repository here. You can find the spec for this, this language. It is really simple. And the cool thing is that within Dapr, if you don't specify something explicitly, then all the messages that are published to the broker will be wrapped in a Cloud Events envelope. And this Cloud Events envelope will have some metadata. And you can use all the attributes of this Cloud Events envelope. So for instance, a unique ID, the source of the message, the version of the spec. Well, you can find everything about the Cloud Events on the Dapr documentation site. But the cool thing is that you can also look in the data. So you can actually dive into the data and create rules for that, as we just saw with the priority field. There is one thing, though, that you have to take into account. This, for now, only works when you have a serialized JSON object as payload in the data field. If you have, for instance, a JSON escaped string, which is also an option, or some other type of content, then this is not yet possible. So that's something that you need to take into consideration. So that's content-based routing. Another really cool feature that they've added is dead letter topics. And dead letter topics, you can use that to make sure that if the Dapr sidecar is not able, or is able to send the message to your service, but the service is unable to handle it, so it doesn't get a 200 OK back, then this message will be sent to the dead letter topic. This is a very common thing with message brokers. Most message brokers support this kind of topology with dead letters. And now you can also light up this feature through the Dapr API. So how does this work? Again, here you see a declarative way of creating a subscription to a topic. In this case, it's, again, the orders topic. And then you can see that we now can add a dead letter topic attribute. And the name of that letter topic will be used. So when the Dapr sidecar sends the message to your service and it breaks somewhere, it will automatically resend that message to this topic. And then, of course, what you can do, you can create subscribers to that topic and then handle that lettered message. And this could be sending an email to an administrator or whatever you want to do, right? So that's basically different logic that is triggered by the message not being handled. Again, as I said, like almost everything, you can also do this in code. So here you see this topic attribute again. We specify message broker as the broker and orders as the topic. And we additionally can specify that the dead letter topic is called unhandled. And then you also have to specify if you want to have a raw payload. This is when you don't want to use cloud events, for instance. But in this case, I want to do that, so the value is false. And you have to specify that because that is the overload where you can specify the dead letter topic. And then below, you see a subscription to this unhandled topic, which can then handle the message. So let's look at how this works in code. I'll go back to Visual Studio Code, and let me go into the find collection service again. And the find collection service, as you may recall, gets the messages for the traffic violations via RabbitMQ, so through pub/sub. And if I now go into the controller and we look at this controller action, you see that it subscribes to the pub/sub broker, the speeding violations topic, and it has specified dead letters as the name of the dead letter topic. So when this fails somewhere, then it will be sent to that topic. And then below there, there's another subscription to the dead letters topic. And then when this is triggered, I will just log some message. I was unable to handle an order, and then I do my best to try to serialize what comes in, because maybe the message is disformed or whatever, that could also be the case. But if I can deserialize it, I will show it for troubleshooting purposes, and else I will say, yeah, I was unable to recognize this payload. So when I try to test this, first of all, let me start the vehicle registration service. Let's do it over gRPC, because we're using Sander's gRPC proxying stuff in here. I'm going to start the find collection service. And now I'm going to trigger this a little bit differently because I'm also going to start the traffic control service, and I'm going to start my simulation. So now we're actually simulating cars going back and forth, and we will see, entry and exits being detected. And then at some time, there will be a speeding violation, and it will be sent to the find collection service, and the find collection service will get all the traffic and owner information from the vehicle registration service. So now what I'm going to do, I'm going to stop the vehicle registration service. So when a message comes in, it will not be able to handle it because it cannot get the details for the message. And here you go. Here you already see that something went wrong. We get a lot of messaging from our logging from Dapr that something went wrong. There was an error because it couldn't reach the vehicle registration service. And then finally, you see that this unhandled message, the service was not able to handle a collect find message, and this was the payload of the message. So you see that this that letters topic was actually triggered, and the service reacted to that. So this is how that works. Let me stop everything here. The dead letter topics can also be combined with these resiliency policies that Sander already showed. So you could, for instance, for pops up, specify that we want retries, or that we want to retry, in this case, a couple of times. We want to do a constant retry with 5-second intervals, and we want a max retry 10. And then after this policy fails, then the dead letter topic will be used. So that's how that works. So let's go to another new building block, the configuration building block.
Yeah, next one. And this is a really new building block.
Yes.
This is still even in very early alpha state currently. Nowadays, many distributed systems, they use these external configuration stores, like Azure App Configuration, for instance, and they use those kind of tools to store the application settings and feature flags, stuff like that. And that's really nice because if you're building a large microservices system, you have a large of many different smaller components, and you want to centrally manage all that configuration. So what this new component type does is it allows you to very easily integrate your Dapr application with those kinds of configuration stores. And let me just show you a scenario of how that works. So here we have our find collection service, and it's November, so the end of the year is coming up, and we didn't quite reach our financial goals with this service yet.
So we are the government now.
We are definitely the government in this case, yes.
Let's crank it up.
Yeah, well, you could say it was good news because great for road safety, right? But not so great for our treasury. So let's see if we can fix this by just adding a little bit of a multiplier to that find. Tweak it just a little bit. So, of course, I want to make this configurable because I may want to change this in the future. So I'm going to put this inside a configuration store. And right now, in this very early alpha state, we've got 3 types of stores that we can choose from. We can put it in Redis, which is what I'm going to show in my demo. We can use Azure App Configuration, or we can use a Postgres database. And then I can use this new Dapr building block to very easily get access to that configuration. Now, this URL that's on the slide here, that's more like an artist impression because there isn't an HTTP API implemented yet. The only thing that's currently implemented is a gRPC API and the .NET SDK, which I'm going to use. But when this will get to the stable version, it will probably look a little bit like this. So you have a configuration endpoint, and then you specify the name of your config store that you want to read from, and you can specify 0 or more keys that you want to retrieve from that store. And if you don't specify any keys at all, you simply get back all of them. So by calling this, I should get back my multiplier, and we can finally reach our goals. Now, what's really important here is that this whole API is read-only. So you can only use it to get configuration from a store into your application. You cannot use it to write configuration to the store. For that, you'll just have to use the tooling of the store itself. If you are in a scenario where you really want to both read and write key value pairs, then you can use the Dapr state management building block for that. So let's see if this stuff actually works. I believe you cleaned up after yourself.
Oh,
Nice.
I stopped everything. Yeah.
Very nice. So let me see, where do we start? Let me show you I should have a Redis running somewhere, yeah? Let me show you that I've already have Redis set up here, and that I can type on this keyboard. I've created a key called multiplier, and it's currently set to 1.2, right? So I want to now use this in my fine collection service. So the first thing I need to do is I need to create a component configuration file for my new configuration component. So I'm going to add a new YAML file. I'm going to name this configuration.yaml. And I believe I do have oh, there it was, a snippet for this. So this is a typical Dapr component file. I'm naming this config store, and this is of a new type, which is configuration.redis. And then I need to specify some metadata so that Dapr knows how the hell to connect to that Redis database. And I'm also scoping this to the fine collection service. So the fine collection service is the only service that's allowed to use this component. So with that set up, I now need to use this component in my C# code. And I'm going to use the .NET SDK for that. So in program, I'm going to add a configuration source. So I'm going to call add Dapr configuration store. And I need to give it a name of the configuration component that we just created. So that was named config store. I can optionally give it a list of keys that I'm interested in. So I'm doing that here. I'm only interested in multiply key. This method needs to be able to call my Dapr sidecar, and for that it needs a Dapr client, and I need to pass that in. So I'm creating a Dapr client using a Dapr client builder and passing that along. And then this timeout here is used to determine how long I'm willing to wait for the sidecar for all of this to succeed before giving up. So now Dapr will make sure the configuration is loaded from the store and it's loaded inside the .NET configuration system. And then we can look at the actual business logic. So I'm going to my collection controller, scroll up a bit. So here you can see in the collect find method, I'm eject just a regular iConfiguration instance, and I use that to get access to that multiplier value. And then I check if it's something different than 1, I use it to update that find. All right, so this should work. Let me see, let me go back to vehicle registration. Let's start this up. And let's start the file collection service. And now with both of those running, yep, both of those running, I should be able to trigger this. So let's trigger a violation and go back to the logging. And here you can see we sent a speeding ticket to Cristobal Sawada. And here at the top, you can see that we've now found that multiply to be 1.2 from the config store. We applied it to just increase that fine a little bit. But, you know, 1.2 is not that much, so maybe we can do better. Reach our goals just a little bit earlier, just in time for Christmas. Set multiply to like 1.5. Go through this whole thing again. So I'm going to retest. That's done. Go back to find collection. And what we'll now see is, oh, if I scroll the correct way, is that we are still using 1.2. Why is that? Well, we changed it in Redis, but it doesn't automatically go into my application code yet. For that to happen, we need to change something else. We need to go back to my program, and we need to add a different type of configuration store, which is called a streaming Dapr configuration store. So what this one does is it takes the exact same parameters, but what it does is, behind the scenes, it uses gRPC streaming to keep open a channel, and then when any values are updated or deleted in my config store, the application will be notified of it, and I will get the new value. Now, it only looks for updates and deletes. So if I now comment out or remove this part, I won't have any configuration value to begin with, right? So it doesn't give me my initial values. So for everything to work, I need both of them, which I think is a little bit silly. I would say that if I want the streaming Dapr configuration store, that I also want the initial values of my configuration settings. So maybe this will change in a later version. But right now, you need both of them. So let me quickly show you that that actually works. So we're starting it again. I'm testing it. And right now, we are at 1.5, because of course now if we started it, it saw that it was changed. But now let's change it in real time. So let's go all the way up
make
to...
Make it 2.
2, yeah?
Yeah.
You think we can get away with that? All right.
We're here doing this session, so we can make some additional money for the end of the year.
Yeah. Okay, so now we've tested again, and you can see that without restarting the application this time, now the multiplier 2 is injected into the code. So this works great, actually. All right, so that's the configuration building block. It's still in alpha states. Things will change and components will be added, but it's looking pretty promising already.
By the way, if you're interested in these kind of new features and the way they are shaped, the Dapr team does community stand-ups once every 2 weeks, I think.
Once a month,
Once a month. You can find information on the site, and you can actually join these stand-ups, and they will talk about features like this. So if you have ideas around how should this work, do we actually need these both these implementations or not, they discuss that in these kind of sessions, and then you can have influence on how these feature will be created.
So final topic.
Yeah, distributed lock building block. So this building block can be used to provide mutually exclusive access to shared resources. So you can imagine in a distributed application, if you have multiple instances of a service, for instance, watching a folder on file system, or something that is not transactional by nature, right? Because many of our transactional resources, you can do optimistic concurrency control or something like that. But sometimes you're not able to do that. But so you need something different. And because we are in a distributed application, you have to have some kind of a shared state to create locks on these shared resources. So this is, for instance, an ideal solution if you have a competing consumer problem. So let's say you have multiple instances of an application running or of a service running, and you need to make sure that only one service at a time is accessing this shared resource. And that is really something you need to take into consideration, that for now, these locks within Dapr, with the distributed lock building block, they are scoped on a Dapr app ID. So it only works for multiple instances of the same application ID. You really need to take that into account. The state of the lock will be stored in a separate component. Obviously, you need some store. And for now, you can use Redis for that. There will probably be additional stores later on, but now it is Redis. And to prevent deadlocks, you can also specify a timeout. So if a lock is not released within a certain amount of time, you can specify this time, then it is automatically released, so another instance can pick up the lock. So that's really nice, because if a service gets a lock and it dies, then you don't want this lock to be, well, indefinitely locked. So that's something that you can use. So how does this work? Let's say we have two services. This is an instance of the same service, but multiple, and they need to access this file system. And like I said, this is not a transactional thing. So in order to serialize access to this folder, let's say they need to pick up a file in a certain order, and they have to wait for each file to be processed in order to pick up the next one. That could be a scenario that you have. And then this becomes this shared resource. And you have to protect this resource to make sure that not two services pick up the same file, right? That's a pretty easy scenario. Well, in this case, what I said, we can use Redis as our lock store. And then we can define a lock component or lock building block here. As you see, this is the declarative way. So this is a component configuration file. We're naming our lock store, and we use as a type lock.redis. So like I said, we're using Redis now, and then we have to specify the metadata to connect to our Redis instance, just as we saw with Sander's demo before. And then once we have configured this, what we can do is, let's say the service on the left needs access to the file system. It will call the API, and it will use the log API, and it will specify the log store. And this name was the name that you saw just now in the configuration file. And in the payload, you specify the resource ID that you want to get a log for. You specify your unique service ID, in this case, service 01, and you can specify the expiry. So this is the timeout for deadlock prevention. In this case, it's 10 seconds. And then when this call succeeds, and there's no other lock on this resource, so the file system resource, then the lock will be created for this service, and this service can just start accessing the resource. If at this moment the other instance of this service wants to get the lock, it does the same call, but now with a different lock owner ID, service 02, and this will not succeed, obviously, because there's already a lock registered in the Redis database for service 01. So once the other service is done with the file, so it processed the file and another file can be picked up, it can unlock, so it can release the lock that it has by calling the unlock API. And it specifies the log store again, it specifies the resource ID for the log, and it specifies the owner ID, so it knows which service it is. And then the log will be released for this service, and then obviously the other service can do a log call, and it will get the log and will be able to access the shared resource. So this is how that works. Just as I said, this is also possible in code. So here you see an example in C# where we use the Dapr client, and we can do a log. We specify the same parameters as you saw in the payload. And if you have a log successfully, you can access the shared resource. And once you're done, you can just call unlock, and it will release the log for you. So that's pretty straightforward. So that's all that we had for you today. Yeah. These are a couple of resources that we want to share. Again, the book, if you want to read it, it looks like we're plugging it, but there's a lot of information on how Dapr works, so it can be really useful. And it's free, yeah. That's true. The eShop on Dapr reference case. The sample application that we just showed you, that's also the sample that we use in the book. So if you want to know more about the other Dapr building blocks that we not talked about today, just check out the sample there. And if you want to know more about Dapr, just go to dapr.io or the documentation, docs.dapr.io. And if after this session you still want to see more of us, then check out .Netflix. That's a video channel that we have with short videos for engineers. And with that, we really want to thank you for being here, and we have time for questions afterwards. So thanks, and have a great conference.
Yeah, and thank you. One more plug for Pascal, who is sitting in front here. He is giving a session at, I think, right after lunch, 1 o'clock, 1:45. And his session is about Azure Container Apps. And Azure Container Apps is this really interesting service which lets you basically run containers in Azure without all the hassle of Kubernetes. But what's interesting is that it has Dapr built in right out of the box. So if you want to get started with Dapr, Azure Container Apps is a really nice way to get into that. Yeah. So that's highly recommended. And we have some time for questions.
And I guess someone was moderating questions from the online stream, right? Also.
Thank you for a great presentation.
Thank you.
Do we have any questions from the audience?
I guess you have to wait for the mic for the people at home.
For the stream.
For the stream,
the live audience.
The suspense.
Thank you very much. I have a question. How does it go with autoscaling? Let's say after some time of inactivity, I kill a service. Mm-hmm. And is there some option that Dapr would help me to spin a container or something like that and make the service alive again if I need it?
There's not something like that in Dapr,
no,
per se.
Typically, if you would run Dapr in a production environment, they recommend you run on Kubernetes. And then basically, Kubernetes will take care of the restarting of the containers for you. So Dapr does not add anything on top of that, on top of what Kubernetes already offers there. And if you run without Kubernetes, you can get some auto-scaling with Dapr, because if you start up multiple instances of your application with the same app ID, then it will start doing round robin of those.
But the number of instances, you determine that. So there's no way of automatically starting new instances, but you can start, of course, 5 instances of a service, and then it will be load balanced by Dapr. But the actual number of instances is not something that will auto-scale for you if you only use Dapr.
I was more like interested if you downscale it to 0, and it will find out that it's not alive, and if it will wait for the service to go alive.
That would be something that you would have to implement using those resiliency policies, and then make sure that your retry intervals are long enough for that service to start coming up again. But this is also really interesting stuff for Pascal's session, by the way, because in Azure Container Apps, you can scale down to 0. And so if you're interested in containers and auto-scaling, definitely also look at Azure Container Apps. Yeah.
Thank you.
Any other questions?
Hello, thank you. It was very interesting. We have seen quite a lot of examples, really, using Kubernetes. Is there any way like to how to run it bare bone without Kubernetes, just the services, for example, just for the developer's experience without any services?
Yes, so what we show you today, all the demos that we did, you saw start self-hosted. The self-hosted is where this is basically just .NET applications running on my laptop, and then the Dapr sidecar running alongside it. So it's just processes. It doesn't run in Kubernetes. This is just, and that's called the self-hosted way of running Dapr.
It actually does even use containers for our own services, right? It's just .NET processes.
Yeah. So the services don't run in containers. It's just .NET run. That's it.
Yeah. Oh, thank you.
Yeah. Any other questions? Maybe from the moderator?
Yeah, we've got
We have, one question from stream, but at the end.
Hi, is there any noticeable overhead using Dapr?
Yes, there is a noticeable overhead. Well, noticeable as in...
Define noticeable.
Yeah, so if you really would profile it, yes, there is obviously, because you're doing an extra network hub. But I must say, you can also, on the Dapr documentation side, you can find numbers, because they do performance tests with every new release, and they are really trying to get this as low as possible, this overhead. So I think that in practice, if I look at 80 to 90% of the projects that I do for customers, the overhead would be negligible. It would be great, because if you see what you get for it, I would happily pay that overhead. If you are building an algorithmic trading system where every picosecond counts, then maybe Dapr is not for you. You must be more bare bones and more native. But I think for most systems, it is fine. It will not be noticeable to your end users, probably. Yeah. Great question.
Okay, thanks. So now question from stream. What is the best way to use different Dapr configuration or different config store, retry policies, etc. for different environments, dev stage, production?
That's a good question. So what you could do is every time you start a service with Dapr, you can specify which folder to use where the configuration files are. So if you do that, you can just specify a different folder for a different environment, and you get a totally different configuration and different settings. What you could also do is that you have multiple configurations. So for instance, you could have a pub/sub implementation with RabbitMQ and Azure Service Bus, but then you have to configure the name of the component in your code. So you have to get that from somewhere, and then you can switch between environments. So there's different ways of doing that. Yeah.
Okay, thank you. Any other questions?
Yeah, in the back.
Oh, good eyes.
Yeah, but the people at home also want to hear what you will ask.
Thanks a lot. So my question is about corporate environment and Kerberos and such authentication stuff. So how do I do this with Dapr? Is it possible, and what are the blockers and things around it?
And then Kerberos for authentication and stuff like that, right?
Yeah, exactly.
That's more you have mutual
Is it
TLS?
I'm thinking about this. Basically, it's hard to go into detail without spending an hour on this, but basically I would say as long as you can get your Kubernetes cluster up in that corporate environment, you can add Dapr on top of that. All of the nasty protocol security stuff you will encounter already at that Kubernetes level. Once you're at that level, I think you're good to go to just add those Dapr sidecars, and you can probably use all of the functionality.
Yeah,
I see. Right. So basically, do it around it. Okay.
Yeah.
Thanks.
Yeah, and it would be wise to basically consider your Dapr sidecar as part of the application. So it's internally. So what you could do, for instance, is if someone calls into a service, you could obviously authorize that by using tokens or Kerberos or whatever. And then when you call into another service within your application, then that goes over Dapr, and you just trust that. But it's something that you need to also take into consideration if your CISO or your security officer also likes that. But you have to think about it as a closed ecosystem, and the Dapr sidecars only do the communication, and that is mutually TLS'd, and that is secured and encrypted and everything. So it's more about how you consider that part of the application or not.
Yeah.
Perfect. Thanks.
Okay, we don't have time for any more questions, but I think you can try, if you have any other question, you can try to find guys at the conference and ask them afterwards.
We will be here all week.
Yeah.
Yeah.
Thank you very much,
Okay,
and have a
thank you.
great conference.